That's the reason why the flask is made to do what? To slant, such that the water that is given out in the reaction does not flow back to the reaction flask. Now listen carefully. Ammonia gas, I told you the other time, is the only alkaline gas known in chemistry. Ammonia gas is the only alkaline gas that should be known to you in your O-level chemistry. And because ammonia gas is alkaline, you know, alkaline solutions react with acids. The opposite of alkaline is acidic. The opposite of alkaline is what? Acidic. So alkaline solutions react with acids. And because of that, ammonia gas should never be dried using concentrated sulfuric acid. Ammonia gas should never be dried using concentrated sulfuric acid, because ammonia gas, being alkaline, will react with concentrated sulfuric acid, forming ammonium sulfate. We are going to see that later on. Ammonia gas, being alkaline, will react with concentrated sulfuric acid, forming ammonium sulfate. That's the reason why ammonia gas must never be dried with concentrated sulfuric acid, because the two will react. And if they react, then you will not form any ammonia which you are trying to prepare. Also, ammonia gas must never be dried using anhydrous calcium chloride, because it will react with anhydrous calcium chloride, forming a complex of calcium chloride diamine. We are also going to see that. So, the only suitable and allowed drying agent for ammonia gas is calcium oxide. Calcium oxide is the only drying agent we are going to use to dry ammonia gas. I repeat, calcium oxide is the only drying agent we are going to use to dry ammonia gas. I think you see how I'm spending a lot of time on this, because I know how important it is. You forget anything about what I have said, then you don't know the chemistry of ammonia. Lastly, ammonia gas is collected by upward delivery. As you can see, the reason everyone can tell, because ammonia is less dense than air. It should never be collected over water, because it is highly soluble in water. Thank you for understanding what I've talked about. So this is the diagram. It stands as it is, but what we are noting is that the flask must be made slanting, because in the reaction, water is formed. So the flask is made slanting such that the water formed does not flow back to the preparation flask, which is hot and may cause cracking of the flask. So, procedure. Assemble the apparatus as shown in the diagram. Grind a mixture of ammonium chloride. This is the first mark you get. Grind a mixture of ammonium chloride and calcium hydroxide. To grind means you use a pestle and a mortar to grind into small particles together and mix together. Ammonium chloride and calcium hydroxide, and place it in a round-bottomed flask of hard glass. So grind half mark, ammonium chloride half mark, calcium hydroxide half mark, flask half mark. NB, the neck of the flask should bend down. This is what I was talking about. Should bend down, and the flask should be in a slanting position. When you are describing how ammonia is prepared, don't forget this is important. Slanting position, because the formed water vapor will condense, and if allowed to run back on the hot flask, may cause breakage. or cracking. I'm sure you understood that. Then you heat the mixture. I told you heat is a condition. Heat the mixture. The equation is here. Calcium hydroxide, I think you have no problem with it. I told you they should be solids, and ammonium chloride, it is there, it should be a solid. When you heat, you form ammonia gas. Actually, it is what we are preparing. Then calcium chloride. The two will just exchange the radicals, calcium chloride plus water. So this is the water formed, and it will condense, and we don't allow it to run back. Yes, so that is the equation. Now, the commonest error that I have seen with the students is here. They forget to balance this equation. Please don't be like them. There should be a 2 on ammonium chloride, there should be a 2 on ammonia, and there should be a 2 on water. Actually, when you are balancing, start from oxygen. Oxygen, these are 2 atoms, so you put a 2 on water. Then you will need to put 2 on nitrogen to balance ammonia. To balance nitrogen atoms. Okay, now the preparation stops here. The preparation stops here. Now, this is the question I was telling you that we usually ask and people fail. The question is, the gas is then dried by passing over calcium oxide. The gas is dried by passing it over calcium oxide, and then it should be collected by upward delivery. That one is here. So we are saying the usual drying agents, e.g. fused calcium chloride and concentrated, this should be concentrated sulfuric acid. We shall collect it in your notes. This should be concentrated sulfuric acid. So these ones react with the gas, they react with ammonia. So ammonia should never be dried using concentrated sulfuric acid or anhydrous calcium chloride, because if you use concentrated sulfuric acid, it reacts with ammonia, forming ammonium sulfate, and the equation is here. So when I ask you to explain why ammonia should not be dried using concentrated sulfuric acid, you say, because ammonia reacts with concentrated sulfuric acid, forming ammonium sulfate. Then you must write the equation. Also, when they say explain or describe, please, if there is an equation, write it. There will be marks for it. So, also it reacts with calcium chloride, forming, this is the complex I was telling you about. It is calcium chloride, tetraamine. Tetraamine means, tetra means 4. So because of this 4, that's why we are calling it tetraamine. So these 2 equations, you must know them. They are important. So that is it for preparation of ammonia. But when I say preparation, this is not a marking point, unless I have asked you to explain why ammonia is not dried using concentrated sulfuric acid or calcium chloride. For you, you come like this. You talk about, I told you, when we ask preparation, you talk about the raw materials, the substances used. Then you talk about the drying agent, you talk about the conditions, if they are there, like heat, catalyst, then drying agent, and method of correction. That's where your preparation ends. Properties of ammonia. Here we go. Ammonia gas is colorless, but it has a choking smell, a characteristic choking smell or pungent smell. Its smell is not good. It will irritate your nose. You will start coughing. Now, some of you, when I ask about ammonia, they will you start coughing. I'm just giving you example of what it means for choking smell. Some people will say it will produce a coughing smell. No, choking smell. Choking means a very undesirable smell that irritates your nose and eyes. Hmm? It is less dense than air, and that is the reason why it is collected by upward delivery. It is very soluble in water. And that is the reason why it must never be collected over water. Remember in senior one, when we taught you about the methods of collection, we would also give you the what? The reasons. It turns moist red litmus paper blue. What does that mean? It is alkaline. Because we know acidic solutions, they turn blue litmus paper to red. I think you're understanding that chemistry. Solubility of ammonia in water. And we usually describe this by using the fountain experiment. But for us, we need to know, what we need to know very importantly is that ammonia gas is very soluble in water. And the experiment is this. It dissolves very fast in water. The experiment is here. You look at it. Fill a dry thick walled flask with ammonia. So this is the flask containing ammonia, and close it with cork carrying tubes and clips as shown. This is the cork carrying the clips, are these ones, these two. Yes, then clamp the flask upside down, let the flask face down, and immerse the cubes with clips inside the water, which has been colored with red litmus solution. So we want to find out if this water containing red litmus solution will turn to blue. If it turns to blue, it means this ammonia that was in the flask has dissolved in what? In water. Open clip B for a moment and close it. This allows a few drops of water to enter into the flask. So when you open this clip B and close it after some time, the few drops of water will enter the flask. And when they enter, you will see a fountain. This is the fountain I was talking about. That's why we call it the fountain experiment. Like the water flowing on top and forming some foam. We call it a fountain. The water is made to run to the round end of the flask. This one is very simple. You will look at it and it is very easy to understand. So that one we call it a fountain experiment, and it is used to show that ammonia is highly soluble in water. Someone is saying, what did I say is used to dry calcium ammonia gas? Happy Revis has answered you. Please, we use calcium oxide only dry ammonia gas, nothing else. So let's look at chemical properties, and the first property we are looking at is with air. And when we talk about chemical properties with air, usually we are talking about oxygen. When ammonia burns in oxygen. Now there is an important point that I want to make here. Ammonia burns in oxygen, or ammonia reacts with oxygen under two conditions. The first condition is in presence of a catalyst, and the other condition is in absence of a catalyst. The first condition is in presence of a catalyst, and the other condition is in absence of a catalyst. The catalyst that is usually used, write something. The catalyst that is used when ammonia reacts with oxygen, the catalyst is platinum. The catalyst is platinum wire when ammonia reacts with oxygen. Now, in absence of a catalyst, nitrogen gas is formed. Nitrogen gas is formed. There we say that oxygen oxidizes ammonia, because you know oxidation is the removal of hydrogen. Oxygen oxidizes ammonia to form nitrogen gas and water. So we are saying this one is in absence of a catalyst. When a lead splint, that is a burning splint, is placed in a jar of ammonia, a gas jar of ammonia, it is extinguished, showing that ammonia does not support burning. On its own, ammonia does not burn, but in plenty of oxygen, ammonia burns to produce nitrogen and water vapor. This means in absence of what? This means in absence of a catalyst, ammonia burns to produce oxygen and water vapor. I mean nitrogen and water vapor. Now, I want to say this. This equation is not easy to balance. This equation is not easy to balance, and some of you will have challenges on it. But what do I advise you to remember? When you are balancing it, just remember that there is a 6 on water. Then everything will balance itself. Remember, there is a 6 on water. If you put a 6 on water, hydrogen will become 12. That means automatically you have to put 4 on ammonia to make hydrogen 12. And you'll put 3 on oxygen to balance it. So this equation is not easy. You need to give it time. Then someone is telling me to repeat the name of the catalyst. It is the next reaction we are going to look at. The catalyst is platinum. But let us first understand this, that in absence of a catalyst, we form nitrogen gas plus water when ammonia burns in oxygen. Very common reaction. Now here we go. In presence of a catalyst. Now this is still in absence of a catalyst, and this is just the diagram. So we are feeding in dry ammonia gas and it is burning in oxygen. Dry ammonia gas is burning in oxygen. Now here we go. In presence, now this is presence of a catalyst. I've already told you the catalyst we use is platinum foil. In presence of a catalyst, ammonia burns in oxygen. Now the product is going to change when there is a catalyst. The product is now nitrogen monoxide plus water. In presence of a catalyst, ammonia is oxidized to nitrogen monoxide when it reacts with oxygen. In this case, the platinum foil continues to grow in the mixture. To grow means to turn to red hot, and this reaction is highly exothermic. Exothermic means it gives out a lot of heat. Brown fumes of nitrogen dioxide are later seen. Why? Because nitrogen monoxide is not stable. So in oxygen, it will be oxidized to nitrogen dioxide. But this is the equation of interest that I was telling you. In presence of catalyst, I'm continuing to say that ammonia forms nitrogen monoxide plus water. Ammonia forms nitrogen monoxide forms nitrogen monoxide plus water. Please, this equation is very, very important. Now, again, balancing it, you should begin by putting 6 on water. So what are we emphasizing? Once again, I'm still emphasizing that in presence of a catalyst, ammonia forms nitrogen monoxide. But in absence of a catalyst, nitrogen is formed. This reaction is known as osteoids. By the way, did I send you the notes on ammonia? Or you mean on nitrogen and its compounds? Someone tell me, did I send the notes?
Yes.
Okay.
Yes, teacher.
Okay, good. So this reaction is called catalytic oxidation. Why is it catalytic oxidation? The word catalytic comes from a catalyst. And as we shall see later, this reaction can lead to manufacture of nitric acid, because from nitrogen monoxide, when it is oxidized to nitrogen dioxide, then this nitrogen dioxide can react with water and oxygen, and nitric acid will be formed. Nitric acid will be formed. This nitrogen dioxide formed here can combine with oxygen and water, and nitric acid will be formed. So this one, we call it the catalytic oxidation of ammonia, and it will form nitric acid. And we shall look at it in detail later on. So these reactions, these three reactions, equations, this first one, second one, and third one, is called catalytic oxidation of ammonia to produce nitric acid. Now, reaction with hydrogen chloride. Ammonia reacts with hydrogen chloride to form dense white fumes. So the same way we said, like carbon dioxide turns lime water milky, for ammonia gas, its chemical property, its chemical test is done using concentrated hydrochloric acid. And ammonia forms dense white fumes with concentrated hydrochloric acid. Because from hydrochloric acid we get hydrogen chloride fumes, which combine with ammonia to form ammonium chloride. And ammonium chloride settles as a white solid, as we are going to see. So this is ammonia coming from ammonia gas, and this is hydrogen chloride gas coming from hydrochloric acid concentrated. However, I want to tell you something which is very important. This white ring, when ammonium chloride settles, you know ammonium chloride can sublime. So it can change, it is formed as a gas, but when it cools, it solidifies. This white ring or white solid, it is formed at the end, which is nearest to concentrated hydrochloric acid. The reason we taught you in senior one, but it is simple. Because you know ammonia gas is lighter than hydrogen chloride. Ammonia gas is lighter than hydrogen chloride. So ammonia gas diffuses faster or moves faster than hydrogen chloride. So hydrogen chloride comes from hydrochloric acid, and ammonia comes from concentrated ammonia solution. But ammonia moves faster. So by the time they meet, ammonia will have moved a long distance. And that's why the white ring is formed near the end of concentrated hydrochloric acid. The reason is ammonia is lighter than hydrochloric acid and diffuses faster than hydrochloric acid. Then reaction with chlorine. So this is the equation for the formation of this white ring. This one here is the equation for the formation of this white ring. This one here. This is the equation. So we are going to stop here for now. Then the other reactions, we shall look at them next time. Can I have questions from you? Any question?